Today we have Stachu Korick, and he's going to tell us about scheduling success with F# web development.
I didn't change the title. Cool.
So, and he's got
I know we have many keyboards, so we'll have a fun demo with that. So, hi, my name is Stachu. It tells me about myself, so we can go into that. Oh, before I get into it, you're probably wondering why I'm wearing a C# shirt. I gave a talk a few weeks ago in Malvern, actually, where I had my F# Fable talk lined up, and then after that there was a C# talk. And of course someone took a picture, posted it to Twitter, and I had a bunch of F# people say, what is that guy doing wearing a C# shirt? So now this is kind of just to troll those people. So, anyway. I love F# more than C#, don't worry. So a little bit about myself. I work at a small company in Pennsylvania. We just came up from Philly. I love F#, of course. I love music, which is why I have this little MIDI keyboard with me. And we will be playing with that with F#. Big into philosophy. I like these little notebooks, and I like talking and all that kind of stuff. These little notebooks. I found a clip art that almost exactly matched the kind of notebooks I did, so it's cool. Anyway. We'll skip past the whole bit about F# in general. I assume everyone here has at least written, 10 lines of code in F#. Does anyone not fit that criteria? Okay. I'm going to skip that anyway. So today we're going to be predominantly talking about Fable. And Fable is basically something that turns F# source code, not IL that's emitted, but the actual source code itself, and translates it into JavaScript. And it very much integrates well with the JavaScript ecosystem. So I remember previously we've had these things like WebSharper and FunScript and Pit and whatnot that have always claimed to convert F# source code or F# IL to some sort of web thing or some sort of JavaScript or whatever. But this is by far the best option on the market, I believe. And it's open source, it's great, and the community is really loving it right now. I'll have these links at the end here, but if you want to get in touch with the F# community and specifically the Fable community, you can do that there. So Fable relies on a lot of different other technologies that have been around for a while. Of course, it relies on .NET, as we're utilizing that for a lot of the server-side type libraries and all the F# compiler and that kind of stuff. We're also relying on NPM and Yarn. We'll see in a bit how those are used. Those are JavaScript or server or client-side technologies. Fable is supported on .NET Core right now. You can go to old versions if you want to deal with the classic versions of it, but right now everything's targeting .NET Core, and it runs pretty smoothly. And it's also utilizing Webpack. So first thing we should do is we should actually see what actually generates from this, because I know at the end of the day people are going to say, what kind of JavaScript are we going to see here? So Fable.io is the website for Fable. It's really nice. It has a lot of samples on their website, and it's just a big overhaul here. But what they have on this Fable.io/REPL is they actually have Fable in the browser. So they've taken this Fable project, and Fable is written in F#. They've compiled it with Fable. So they're basically dogfooding in that sense, and they're actually utilizing that here. So in your browser, everything's client-side here. It's looking at your F# source code. It's compiling your F# source code into JavaScript in F# JavaScript, and then it spits out the response on the other side here. So we can see if I go down here to the samples, I can choose ray tracer, which will pull up this sample 200-line ray tracer. If you don't know what a ray tracer is, you're about to find out. If I hit compile here, it'll go through that whole cycle of compilation, and it'll spit out some JavaScript here. So it's ECMAScript 6, ES 2015, whatever you want to call it. It has a lot of import statements, and generally it's pretty legible. Even a normal JavaScript person can probably interface with it pretty well. And compared to that 200 lines, we have somewhere around double of that in the output. So nothing too crazy in terms of code length or anything like that. But we have this code that is written in raw F# code, and we have it translated or transcompiled, whatever you want to call it, to JavaScript, so we can work in that environment. And if I run this here, and if I am patient, we can see that right here we don't actually have an output scene for ray tracing. What ray tracing does is it basically prints out some images here, But if we go to a simpler something, such as a Sudoku solver, which if you're not familiar with Sudoku, is some kind of puzzle with numbers and such. But they've written this solver here, and down here they have some utilizations of it, where they try to get the first solution. They import a specific matrix that represents the Sudoku board. And here, if I compile and run this, I can actually see the output, what the actual solution to that Sudoku puzzle is on the left there. So it's pretty cool. You can do a lot of just raw F# to JavaScript translations, and this is all cute because it's just text-based. You're not really dealing with the web itself in terms of interfacing. But in a minute here, we'll see how we can actually interface with the web in addition to all these little direct translations here. So that's Fable in action, just really simple version. Let's go back to this. Okay. Another way we could interface with Fable in the Fable compiler is we could do it through the command line. I'm not going to go into this for time's sake, but basically, this is actually a little bit outdated. But what you could do is you can download Fable, basically call it with an F# script file, an F# source file, or an fsproj, so project script or the regular code file. And from those, it'll take the abstract syntax tree that the F# compiler service generates. It'll convert that AST into an intermediate AST. So Fable has its own little AST that has under its wing, and it converts it to something that Babel can utilize. So Babel is something that's out there that can basically take this abstract syntax tree and convert something into JavaScript. It does a few other things, but primarily, you get the point. It's a bunch of abstract syntax tree conversions, and eventually we get the output JavaScript code. So all Fable's doing is it's trying to get it so Babel can understand it, and Babel does the rest of the work. So the F# community has utilized that world under the hood. If you want to build a Fable project from absolute scratch, there's 2 really good blog posts down here about that. I'm not going to go into that. That takes 20 minutes. What you want to do is actually get to an actual template and start from there. So how many of us are familiar with .NET Core, played around with .NET Core? Cool, so about half. So what we're going to do now is I'm going to enter the rest of you guys into the .NET Core world for a minute as we go into a quick console. Oh, that's not what I want to do. So I have Visual Studio Code open here. It's my development environment of choice, and more importantly, it's pretty much the only thing that works super well with Fable. JetBrains Writer works pretty well, but Visual Studio, that enterprise-y thing doesn't really work so well. Maybe someday it will, but for now it doesn't. Please excuse the fact that this is Fable Minsk. Most of this talk is similar to other talks, so I left that there. Anyway, so what we have here is I am in this root directory of this project. I'm just going to follow the steps I have here. So .NET new -i Fable template, what that's doing is it's basically downloading from the repository of templates that exist in .NET Core the specific template around Fable. So what the Fable people have done is they've basically taken the equivalent of what you would get in File New Project in Visual Studio when you create a C# project or something like that. They've created a template for that, and whenever you install this, you can then utilize it. And you can say .NET new Fable. So if I go here, I can say .NET new Fable. And what that's going to do is it's going to actually download that template, which doesn't have too much. Okay, I'll do this. So that's just going to So I'm going to install that app into a project here that's just test, and that comes with a number of different things. So the first thing that we're going to need to do when we utilize this template here, and this is effectively what you do the first time you basically create any project similar to when you do File New Project, is you want to go into that project, and I hope this is legible to everyone. Is it not? I can make it a little bit bigger. Okay. Yell at me if you need questions or if you can't see anything. Anyway, so now that I'm in here, I'm going to clear the screen so I can move this up a bit. And then I can do a yarn install. And if you know what NPM is, you basically know what yarn is. It's basically a replacement for NPM. NPM is a package manager for the JavaScript in the Node world. So what we're doing now is we're just downloading the probably 1,000 Node packages that this has dependencies on. And it's going to put them inside of our Node modules. So parts of Fable are written in JavaScript and parts of it are written in F#. just because the JavaScript was somewhat easier to write for certain circumstances. But basically, it's going to take a second here, and that's going to download all those type of dependencies. I've almost all lined up. There we go. So now what we need to do is we need to go inside of the source folder. Inside the source folder, we'll see a few things, not too many. We'll see an app.fs, which is going to include our F# code that's going to be compiled down to JavaScript in the specific project that we downloaded. And we have a packet references, and we'll get into a second what packet is. And we have our fsproj. And our fsproj is our project file here. So packet, if you're not familiar, is an open source F# project in which it's basically a replacement for NuGet, and actually relies on NuGet for a lot of things. So there's some features that come with packet that aren't in NuGet. You typically, one of the big things is lock files. So let's say you have Newtonsoft JSON and 3 different projects in your solution. Well, you probably want a specific version to be in all 3 of those. I know I've run into solutions where you have 3 different versions, and you have a conflict, and you have just this awkwardness, same thing for any framework. It's so what packet does, or paquet is actually the pronunciation, is it takes that dependency problem that it takes it away. It basically enforces a version number at the root, at the solution level, and all the projects have to go from there. There are some other features as well, but that's the point of packet, is that it has some features on top of NuGet, or a replacement of NuGet. Yarn, as we mentioned before, is basically the same thing, but for the Node and the JavaScript world. It's just a replacement for NPM that has a few niceties here. So what we're doing now is I'm doing a .NET restore, and .NET is basically the command of .NET Core. Whenever I need to run a .NET, any framework migration, or I need to run tests, or whatever I need to do, I'm probably going to call some form of a .NET command here. And specifically, what this specific call is doing is it's going to download the NuGet dependencies and all the other kind of dependencies and do that kind of groundwork. So now that I've done that, I can do .NET Fable yarn start. And what that's doing is it's opening up 2 different processes. It's opening up a Fable process. It's also opening up a web client, or sorry, a web server for our JavaScript to actually run on. So right now, you can see here that, if I scroll up, we have a Fable daemon that is sitting on a specific port. Yep, so right here we have a Fable daemon sitting on a specific port. So basically, you can imagine there's this little web thing that's waiting for requests, and whenever I feed it F# code, it's going to do all those conversions of those ASTs and everything, and then it's going to spit back JavaScript. That's a little bit simplified, but that's effectively what that's doing. And the Webpack, the server that is being run with Webpack, is going to be calling that every time a file updates. So every time, now that this project is running, every time I update some kind of source code, this will automatically be refreshed. We have some nice hot loading feature. So if I go to the source code, so we can actually see what's happening here, see some more realistic Fable code. We have pretty simple F#. We have a few opens, just opens the namespaces and such. We built a canvas object or value, and from there we can manipulate it. So again, the benefits to Fable, as opposed to just writing raw JavaScript, are very much in line with the benefits of using TypeScript. But in addition to the benefits of using TypeScript, where you have static types, in Fable, of course, we have the benefits of our fantastic type system, type inference, all that kind of stuff. We can also utilize a lot of .NET libraries as we're going here. So right here, we basically created, we've given ourselves the ability to work with JavaScript type things in a very typed world. So if I call canvas dot off of this, and if I wait a second, I can see everything that would be on that specific object. So there's bindings here for everything that exists. So pretty much anything that exists within your browser natively, you're going to have automatic typed bindings that are in Fable here, which is very nice. Because then we can do things like this, where we can create something like a canvas printout, which is still pretty simple. and we can do this in a very typed fashion. So here we have that simple usage. It just creates two squares, cute, and that's basically what that's doing. So if you look, if you're trying to figure out, okay, so what's printing out this text? Well, what we have here is we have a public folder here, and that just has an index.html, and all this does is it basically, you have an H1 for that using HTML canvas, and we have this bundle.js. That bundle.js is what the Fable daemon is compiling down to. So if I were to look, well, basically, it's going to look for that specific bundle.js, and that's going to be the compiled JavaScript there. So that's a pretty simple Fable sample. That's going to be what you see if you download the template in .NET Core. And the instructions are pretty available online. And so now what we can do is we can look into a little bit more Fable, hence the title, more Fable here. And we can see how we interact with the JavaScript world a little bit more here. So we can see, what things compile, what things don't. So basically, I have this app.fs, and in a second, we can load this into our browser here. But effectively, we have a few open statements. You can see we have Fable Core JS interop, and we have Fable import browser. So each of these specific namespaces have bindings for something in the JavaScript world. So the way Fable works is it doesn't necessarily have to emit JavaScript code itself. If we have JavaScript code that we call to, all we have to do is create bindings. So things like Fable import browsers, of course, they're not writing the code that your browser is running in terms of what's underneath the hood when you're calling give me a specific object or anything, or give me a element by ID. Instead, what they do is they write bindings for it, similar to how TypeScript has TypeScript definitions. So in any case, we'll get into TypeScript definitions in a minute here. But you can see we have different options for outputting text. We can printfn, or we can console log, or whatnot. Console, of course, is something that's typed here. If I hit dot, I can get log, I can get error, I can wait 20 seconds and hope this works. Nothing better than a demo, right? Oh, I think the other thing's still running, so this okay, I need to go to the other project quick. So if I'm in here, I can run this project, and we can see what it actually outputs here. And that's going to actually throw me an error here. Any questions about Fable in general before we get any deeper? I know there's a lot of content we'll be going through tonight. Cool. So if you can imagine what Fable has to do is everything that's in basically .NET Standard, or a very small subset of .NET Standard, the F# people have actually rewritten a good portion of that in F# itself to be translated. So the thing is that we're not just going to magically write a compiler and then everything magically translates. Instead, what they have to do is they have to rewrite a lot of F# in JavaScript itself. So everything where I have a list or an array, all these F# native types, they have translated into JavaScript. So we're not going to see too many samples of failure today, hopefully. But just keep in mind as we're going through things, or if you decide to explore this later, that certain things in F# might not exist in Fable, or might not translate well. Many things do. Events translate, code quotations translate, etc. But certain things don't. I just want to throw that out. So we have a very exciting screen here. It says click me. And we'll get to that in a second here. So if I open up my console, so this is my browser, I can see all of the garbage I'm printing out. So we have two different ways to output text. We have Fable running, hi there, whatnot, and we can do whatever we wanted to in terms of special versions of this or parameterized versions of the printfm, etc. And we can work with the native F# code as we would before, as we saw in Fable REPL. But once we start to try to interact with JavaScript, things get a little bit interesting. That's what a contractor says when they don't want to say bad. So certain things don't exist natively in Fable or F#. So we have to create bindings for it ourselves. So undefined doesn't exist in F#, thankfully. But we have to sometimes deal with the consumption of undefined when we're interfacing with other JavaScript libraries. So what we can do to interface with this JavaScript world is we can define functions that are of the type we want them to be or what we would expect them to match on. And we can decorate them with this attribute emit. So right here, if I ever in F# write console log undefined, because I have declared it up here, what it's actually going to do is it's actually going to translate it to the text undefined. Mm-hmm. So you can see that usage later. So that one's not very interesting. So a more interesting version of emit and its usage is something like this, where you actually have a function that's in JavaScript, whether it's natively in the browser or whether it's in some JavaScript like jQuery or something that we want to interface with. If we want to deal with this, what we can do is we can create this sort of binding here, where I can say is undefined, takes in something, don't really care what it is, and it's returning a Boolean. And all you do is you assign it to JS native because it's not in our world, it's in JavaScript's world. And we can parameterize it like this, where I have the first parameter, and we check if it's equal to null. So you can see how this would translate and how that would pick up on it. So basically those uses would all work. So if I check undefined against all these things, we would see the expected answers. You can run through that down if you'd like to see proof. In addition, we can have parameterized functions that that look for certain operators in JavaScript world, so it directly translates. And we can do that. So we have two parameters there, and we'll respectively add them, and etc. So isNaN, you could add support for that. If you wanted to grab the native math.random instead of using .NET's math.random, you can do that, etc. And all these you can look for in your spare time in terms of how they translate and what it specifically works. There's a good page on the Fable website that has a listing and compatibility list of what does translate and what doesn't translate from F#. But if you have questions about that specifically as well, we can talk to it. So that's raw Fable. It's pretty interesting, and it's pretty useful. But a lot of the time it's not enough. I don't want to have to write all these emits. It's kind of time consuming, and I'd rather an easier way because I'm a developer, so I'm lazy, whatnot. So what we can do is we can utilize the years that TypeScript has been around. We can look for TypeScript definition files, and we can compile those to F#, and then utilize those bindings. So we'll get into that now, and then we can play with the keyboard. So TypeScript definition files are for things like jQuery. So jQuery's been around for, I don't know, as long as the web has been around almost, it seems. And it wasn't written in TypeScript to begin with or anything, right? So when TypeScript people wanted to finally interface with this ecosystem, because jQuery's there, whether you like it or not, they had to create bindings for it. So if you're not familiar with TypeScript, it's basically a statically typed language that compiles down to JavaScript. But in any case, they had to create these definition files. So I'm going to show you two definition files here that are going to be in conjunction with this little MIDI keyboard, and we can see how they translate well. So if I go to, there's two specs out there to deal with noise in browsers. We have the web MIDI spec, and MIDI is basically a language design that contains information about events transpiring. So whenever I hit this specific key, I get a message that goes out of this USB port in my laptop that says, key on at this velocity, some number between 0 and 128 or 127. That's basically saying, how fast am I hitting it? And I also get information of, which MIDI keyboard am I connected to. So MIDI's been around since, I think, 80s, maybe earlier. It's been around for a very long time. The spec actually hasn't changed drastically at all since then. There's still 1.0 after all that time. Anyway, so this MIDI spec's been out there for a long time, and what certain browsers, especially Google, have vouched for is basically allowing us to interface with MIDI in our browsers themselves. So currently, Chrome supports MIDI, so I can work with these devices in my browser itself. So of course, I, as a theoretical TypeScript developer, want to play with MIDI because it's fun. So what I do is I create a definition file. And what definition files are, they're basically interfaces for dealing with existing JavaScript. So if I look for a web MIDI TypeScript definition file, if I finish that Google term, I eventually find this. And if I wait a few seconds, I get this. So we have here is a TypeScript definition file. And as I mentioned, it's basically a bunch of interfaces and like theoretical code, basically something, a contract defined after the fact that matches something that exists. That's what a TypeScript definition file is, typically. So, we see we have this web MIDI namespace that exports an interface, etc. So, that's how TypeScript people dealt with all these existing things. They would create a definition file. They would add that to their TypeScript source code, their project or whatever. And then they'd be basically interfacing with this, knowing that under the hood, the other code worked there. So on their client side, they'd be referencing jQuery or whatever. And then they would be referencing their definition file. And then they'd be actually calling the definition file, or not calling the definition file, but interfacing and be tightly bound to that definition file when they're actually working in their language. Which is all fun and games, but it's not F#. We love F#. So we're going to do that. So we have this project out here called ts2fable. And ts2fable is, as you can guess, just something that takes in TypeScript definition files and emits Fable. Because at the end of the day, if we just want bindings for something that already exists, we can basically do the same thing. Just have a bunch of interfaces that we bind to, that we know are going to translate well to JavaScript, then we can work with that. So if you want to play with ts2fable, it's basically what you do. Download your definition file. You can npm install ts2fable globally, and then you can just treat it like a command line application. So I'm going to download this here onto my desktop. I'm going to put it there. I'm going to go here. Oh, what is this? WTF#, that's a podcast I'm starting. You should check out soon. Intermission here, I guess. I've been toying with the idea of starting an F# podcast for a few years now, and I'm starting to actually finally do it. I have a few guests lined up. I have a domain, WTFsharp.net bot, because great name. And we got this designer to do the logo, whatever. So anyway, so follow me, Twitter, whatever you do, and we can talk about WTF# if you want to air on the guest, or if you want to guest sometime. I'm open for it, but I'm really excited for this whole opportunity. I hope to have the next episode up within the next week, unless something terrible happens, which things always do. In any case, oh no, I got distracted. So that was cute, right? So I'm gonna open up this console here. Let me keep the F# on the screen. So, so what I can do is I can go down, down, down. Is I have ts2fable downloaded globally as an npm package. And when you do that, you can basically use ts2fable as a command line application. And if I call ts2fable, and I call it with this web midi.ts, if I call it just like that, I will actually take up the full screen. What it's going to do is it's basically going to translate it and just throw it onto the screen right here, the F# code that it should generate, or that it thinks we should bind to in F#. So you can, I'll give you a second here to soak this in as to what kind of stuff is being output. It's basically the same thing. It's basically a bunch of interfaces that we're going to be bound to here. Just empty types. But right now, they didn't really create a file, so what I can do is this little command here. I can say web, actually let's call it fable.import.web midi.fs. And of course, that's just going to take that stuff we saw on the screen, it's going to put it in a file here. So if we, oh, what's that cool logo? Anyway, so if we go here now, we can see we have this Fable import, and that's just the exact text that was in there. So I did that, so that's one thing that says web MIDI exists. In addition to WebMIDI, we have this thing called Web Audio. WebMIDI is only supported on Chrome. Web Audio is supported pretty much everywhere except for IE, because IE. So Web Audio, imagine I did the exact same thing. I found a TypeScript definition file. I converted it to Fable, something that's Fable friendly with this tool. So if I jump back to VS Code and I go up a bit, oops, I can go inside this other folder here where I do a TS to Fable demo. By the way, if you're looking for slides or anything like that, the slides are already online, and the code is already online. I have to update the code a little bit, but you can just look at my GitHub for that. Okay, so if I go here to TS to Fable demo, and I say .NET Fable yarn run install. If I go into the source directory first. And what this is doing is it's taking this code here, this fsproj, and it's compiling it down to JavaScript. So you can see I did that TS to Fable thing with WebMIDI, and then Web Audio, and then app. App is, of course, dependent on those, which is, I always love the thing about F# is that when you want to figure out project, you just look up, start going down, because of the dependency graph, or the backup graph there. Oh, not yarn run install, just yarn run. Maybe not. The versions of Fable have often changed how these things are supposed to work. I see. There's a medley of the 5 things I tried. So, so here we have WebMIDI, and this is the pretty much the exact same thing that we saw before. That's output. Realistically, every time TS Fable runs, you have to clean up some of the bad things it does. So I think I changed maybe 4 lines of code here to compile. And then I did the exact same thing with Web Audio, which again just creates a bunch of stuff. And then I have this, which is the fun part. And if we are patient, it's almost finished. We have something over here, a large text. More importantly, that text though is we have stuff going on here. So I won't touch the keys yet because it will make noise, and I don't know how loud that's going to be. We'll get there in a second. So I'm just going to take you through this so we can kind of get a real feel for if I wanted to play with something in JavaScript, but I hate JavaScript, how would you do it? So this is basically my experience doing that in a coffee shop in a day. So Navigator doesn't natively exist in Fable. Navigator is basically an object that I can get the context of the web MIDI and the web audio. So what I can do is I can just basically say, give me a navigator, and I can use that embed we use, and that's the only time we're using that in the source code. It doesn't come up too often. What I can do then is I can create an audio context. Audio context, just that context, that ability to emit audio from the browser. I have a mutable, don't kill me, oscillators array. Mutable because we're dealing with JavaScript, and sometimes it's just easier dealing with mutable things. And from there, we have a number of things that manipulate these objects here. So it's really cool, just with a few lines of TS to Fable hacking away, I can go to a specific oscillator, and if VS Code is happy with me, here I'm going to actually restart VS Code because it's not doing what I want it to do. I think it's because of the C# string. Anyway, so if I go in here, I go 04, I have this run again. For some reason, INI isn't playing well. INI is actually, it's a good thing for that. So INI is a tool written in F# that is an extension for VS Code. So all the interfacing I'm dealing with VS Code, where I can do all these really cool things, is actually built by an open source developer. And given this extension built into VS Code or installed from VS Code, I can do a lot of cool things like install NuGet packages via Packet, etc., all within VS Code without having to do a bunch of hackery. So it makes a really good support for the for F# in VS Code. So here, oh, excuse me. I don't know why it's not playing well for me today. Anyway, so the IntelliSense isn't quite working for some reason, but effectively I have these bindings here. So I have that the oscillator array. I have the ability to play a note, which basically mutates a specific oscillator. There's one oscillator per note. It's much simpler dealing with that and much more performant if you just have one oscillator per note that you turn on or off, or per frequency rather. You have a function that stops a specific note given a frequency. You have a conversion that takes a MIDI message, or a MIDI note, which is some number from 0 to 127, because it's a long time ago they really had to save on space, and converts that into an actual frequency like 440 hertz that we want to output into some kind of wave. And then we're going to wire up a response to a MIDI message. So there's 3 parts to a MIDI message. There's what controllers are coming from, there's what type of event is firing, and there's what velocity is it being fired at. So if I hit this note really lightly, I get a velocity of like 2. If I hit it really loud, I get some louder velocity, etc. I kind of skipped ahead there. But anyway, so we have these different velocities, so we can take apart these different parts to be then converted and then used for web audio's sake. In any case, whenever we get a web MIDI message, or not web MIDI message, but a MIDI message, we want to print out what data it is. So if I jump over here, you can see there's certain data being output. 127.62.0 or 128.62.0 is basically noting that returning note 128 off, or sorry, no, returning off note 62. So 0 is the velocity here, 62 is what note we're going at, and 128 is what type of event is actually happening here. A layer on top of this, which I'm not displaying out, is which controller's input. So if I had 50 of these things and I had one in each of your hands, we would also have that data, so we know who's doing what song. In any case, so we have this data, and from that, we're going to get the frequency from that note 62, that MIDI note. We're going to find the frequency, we're going to call our play note function, and then once we have this wiring set up, we can actually use this wiring down here, wherein for all of the devices that exist in our navigator, we're going to wire up such that whenever you press something, it responds. So it's pretty cool. Allows you to do all this kind of stuff.
It missed the off.
What was that? Yeah, missed the off. You're waiting for that? I played it too fast. But it's pretty neat. If you haven't played with these MIDI keyboards, they're actually pretty cool. If you hold down, if you hit this arpeggiator key, and then you hit a few things, you get all kinds of cool things, like it'll automatically do some kind of circuits like that, which is cool. In any case, if you want to check out that code, it's all online, but that's a quick toying around with how you would deal with playing with JavaScript type things within the Fable world. You could extend this and keep on going and use it with any other frameworks that are in the JavaScript ecosystem. Let's say you wanted to build something with Angular, but you want to use F# for it. You can do that if there's TypeScript definitions, especially. If you want to do something in Vue, or if you want to work with a specific API that had bindings in JavaScript or TypeScript, you can do all that. So right now I just did a nice little cute app, but if you want to do something real, you want to build a full application, just totally replace TypeScript in your world, and to replace JavaScript, you can do that, and it works pretty well. There are some caveats, as I mentioned, that are listed on the website, but most of the time I haven't had issue doing anything I wanted to in Fable Raw. So I say Fable Raw because we're about to get out of Fable Raw into Fable Elvish. Does anyone have questions about Fable itself before we go into a different universe here? Nothing. Okay. I'm going to assume that you guys all understand everything then. Cool. So I have to make a confession. So I love F#, and I've been doing F# for, I don't know, 4 years or something like that. So it's not that long, but as far as F# goes, it's one of the older guys. And I love F# and I've been doing it for a while, but there was this 6-month period where I cheated on F#. for this language called Elm. Lovely language. It basically takes one language and then compiles it down to JavaScript and HTML. Luckily, I don't need Elm anymore. It's like a Fable Elmish. What Fable Elmish does is it takes the architecture that this Elm language utilized, and did a very good job of it, and it now binds it to F#, so I can write full Elmish like applications in F# using this library called Elmish. And we'll see what this actual model view update architecture is just now. So model view update, also sometimes referred to as functional reactive programming, has three parts to it. It has a model, a view, and an update. And so for the next bit, what I'm going to do is I'm going to pretend that I am Elm or I am Elmish. So let's say instead of just having functions that mutate some state that's somewhere, I maintain all my state in a single box. I have a single box that I carry around with me, and it is the state. It's my whole database. It's whatever. And or it's at least the state of everything that's visible. Let's say of a specific page or dynamic page setting. So I'm holding that state, and it's pretty useless by itself. Who just wants state? So I have to introduce something else. I have to introduce an update. So an update is basically something that takes in a message, which is basically some intent, some user interaction. It takes that model and it creates a new model from this piece of information, and it says, this is my new model, this is my new truth that I'm working with. So my whole state, my whole application truth is in one specific thing, and whenever I hear about something happening from the client, I say, oh, okay, that state's no good anymore. I'm going to take that old state, reflect what the intent from the user is, and then mutate my state, and that is my eternal state. So you can think of this state as an aggregate, and you can kind of think of it as an event sourcing model or a change-driven development model, in which every change I have is reflected on the aggregate state. And we'll see what I mean by that a little bit more in a minute. And of course, the view is just something that takes in a model and it outputs some view, whether that view is HTML or that view is WPF or whatever it is. It's something that takes in a model and it outputs something. And of course, what we're going to see today is HTML. We're talking about web, but it could be potentially used for something else. So that's what Fable Elmish does. That's what the Elm architecture kind of is. That's what model view update is. It's the ability to just have all your data aggregated, and you have the ability to just listen for specific, a limited number of events that are all listed out in one centralized location, potentially. And then whenever you're updating that, you take that new model, and then every time you get a new model or an update, you repaint the screen with the view function. So that's the job of Elmish. So a quick example in F# with Fable Elmish. So here we have a very simple application. You wouldn't get paid much for this. We have a counter. And this counter has 3 buttons and a number and some text. So you can imagine the HTML for this. It's literally 3 buttons. I forget the anchor tags. We'll see in a second. We have some kind of dynamic text that changes when I would click this button. I'm not going to actually click this button because we're going to the next slide. And we have something that increments, something that decrements, and something that resets there. So how would we represent this in a Fable Elmish application? So the model, again, is 3 parts: the model, the view, and the update. The model is pretty simple in this case. We actually have more than one part of the model. I kind of lied. We have the model itself, which is our aggregate state. In this case, our aggregate state is just an integer. It's just that number we're moving up and down or resetting. We have our message, which are all of the possible ways in which our aggregate state can change. So you can think in an application, some kind of state, some kind of message here would be user click the back button, or user right click this thing over here, or user hit the space key. Things like that could all be events that fire off. Really, you would aggregate a lot of those things into more powerful messages. But here we have a pretty simple domain model of just an integer. So we have one message. So this message here is the thing that's going to be passed to Elmish to update the aggregate state, which will be utilized in its update thing in a second. And finally, after we've given our model of type alias of an int, and we have a message which is a discriminated unit of increment, decrement, and reset, we also have an init. And an init is basically what's the initial state of our aggregate model. For right now, please ignore this star and command message and this list here. We'll get to that in a little bit. So given our model, we need to do something. We need to output to the screen given that data. So we have here is we have that exact thing. We have something called view that takes in a model, also takes in dispatch, which we're talking about in a second. And we have a little helper function here, which creates one of those buttons, which basically listening for user input, and whenever it does user input, it'll do something specifically given by this parameter here. And that's all. It's just a nice little helper thing to create a little button here, or an anchor tag with a button class. This is using Bulma, if you're not familiar with the CSS framework. Then finally, we have a div inside of this. So this effectively looks like HTML, but it's not quite HTML. It's it's F-sharp HTML. So I'm going to make you guys a little bit less confused as to what's happening here. So each of these things here, like div and like a and like str, are basically they are functions that are being translated. So this div here is a function that takes in two lists. First, it takes in a list of attributes. So class name, href, those kind of things, and it also takes in a list of children. Sometimes it will have no children, especially in the case of an input which cannot have children legally. It's a zero child policy. And then, et cetera. It's those kind of things where we have a number of different attributes and then a number of different children here. So in this case, we have a column that has no children. It has a class name column. You get the point. You can play with the syntax a little bit. In any case, so this is our main div. This is what's being returned from our view. At the end of the day, we have a div that has columns, which is basically like a grid system in Bulma. And we have a column that's just blank for some spacing. We have a column specifically for the actual value here. So this is what's being, if I go back here, this is what's being run on the left. We just have counter value and the colon and 0, or whatever the state is, which we're just outputting here. Nice sprintf function. str is just print out plain text. And then we're utilizing our helper function from here down here. So I mentioned before I would get back to that dispatch. So that dispatch is a function that is called to talk to Elmish. So every time a user does something notable that we want to interact with, let's say I click the +1 button and I want the state to aggregate or to increment, I would send that specific discriminated union value, and I would call the dispatch function here. So this specifically increment is being input to here into that action, and that dispatch function is being called. So every time I click now, I'm wiring up this thing that I take in the event. In this case, I'm ignoring the event that all the data that you're using when you click it. I'm taking that action and I'm dispatching it. So with that helper method, I can really cleanly have that code there. So that's Fable. That's basically what Elm looks like as well. If you look at Elm, that specific language, you could basically take Elm code and take it into Fable Elmish and almost compile. Almost. Yes?
Is it looking for that specific type of message that you declared on the top, or it can be named anything?
It is looking for message. Well, I mean, because it's F-sharp, it's looking for whatever fits it best, but it is specifically looking for message in this part. So that discriminated union of the increment, decrement, and reset, that's what it's looking for in this case. So we're just taking that view, taking a model, and taking the dispatch, and we're returning this view that can later call us back. So in addition to the view and the model, we of course have to have an update, and we have to be able to deal with state change. So update is really nice, and we can see everything, every possible state change in our application in one function, which is kind of cool. So again, this is pretty simple F-sharp code. It's just pattern matching. So what it's doing is it's taking the message, the specific intent that the user gave to me. It's taking the old aggregate state, that old model, and it's returning a new model. So of course, we're all used to implicit returns here. And what this is doing is it's matching on the specific discriminated union. And if it's the increment, then it will just return the old aggregate state +1. So this is pretty simple, and we'll see something more complicated in a minute. But that's basically how FRP works. You have these 3 layers, which can be componentized, and from there you deal with aggregate state at different portions, and you kind of think of events as something really, you think of change in your system into something really important that you should be able to reflect on really simply. So right now, I can look at that discriminated union up here, and with a single line, I know everything that can possibly happen in our application in terms of state change, which is something that is really useful for showing up to business people, domain users, etc. So just keep that in mind as a nice plus here. So that's Fable Elmish, and we'll see a lot more of that in a second here. So it's just implementation of the model view update pattern in F#. There's a lot of really good documentation out there for Fable Elmish. If you're interested in that, then I would check out the documentation. In addition to that, if you're interested in this architecture, check out Elm. There are a lot more Elm talks than there are Elmish talks, and pretty much everything translates one for one, or quite close to it. Okay. So I built a bad-looking scheduling application because I'm a neurotic person who needs his life to be scheduled. And I did that in F#, of course, because why not? So we can look at that code now, and we can kind of see how that's built. Okay, so again, this is all mine if you want to look at the source. So I have this scheduler here. And I have a few source files here, so I just have maybe 10 files here. I think this is the right one. No, caught you up. It could be anything. The versions of these commands have changed frequently.
What are you putting in the subdirectories input and output versus what you're keeping at the top?
Components, effectively. So if you were to take your whole application, the visuals of it, and you wanted to componentize things or turn things into modules that are kind of independent for the rest of the application, that's what, in my specific case here, these are views, the input side of the view and the output side of the view, but you can do whatever you want. So we'll go through the source code in a second. Any other questions? Cool. By the way, right now, the creator of Fable is speaking at .NET Conf, literally as of 5 minutes ago. This is Alfonso.
Yeah.
Let's see, I could choose. But so he's giving a talk that we want to reflect on later. Nice. Go for it. So pretty cool. We're at the same time. He's in Spain right now. There's actually a conference on Fable this weekend. So all the cool Fable people are in town in Bordeaux. They're drinking their wine and eating their cheese, that kind of stuff. And they're going through that. So here, he's also talking about Elmish, but good timing. Wish I was there. Anyway, so have I stalled long enough? I have. Good. So if I jump to my browser, don't judge my styling. I'm colorblind and not artistic, generally. This is my scheduling application for myself. It's pretty simplified here for this use case. But basically, let's say I do 3 things in my life, because I'm an adventurous man. I do yoga, I go to work, and I drive home. I never drive there, apparently. I just drive home. So, and I have very limited functionality here, but it's something to see a slightly larger application than a specific, just a counter. So I have names of different tasks that I can change. I have, which as soon as I type them are reflected on the right-hand side. I have start time and end times when I expect to be done them. I have buttons where I can delete a specific event or add a new event or a new task. And I can also toggle the frequency between daily and weekdays. Of course, naturally, some things you only do on Tuesdays, that kind of thing, but simplified, you get the point. So right here we have the input side of things, which is in one folder. This right here corresponds to a component I call single task. And this whole view right here is something called input that utilizes single task per row. And over here we have the output, which is just a tab delimited list of days in which I can see what I'm supposed to be doing that day. So on Fridays I do yoga at ISDF, and on Saturday I don't. So that's that, and then if I of course change this to daily, that will reflect there. So pretty small application, but we can see how we work like this. So again, I think I mentioned before, one thing I really like about F# is the ability to easily see how things are built, because all I have to do is I have to go to the FS project folder or file, and then go through these files in a linear fashion, and then I know what's happening. I don't have to jump through hoops, so I have to reference this service, which references this. The dependency graph is very thin. It's a cyclomatic complexity as well, as you could say. So here I have models. That's the first thing I'll go to. I don't want to update or anything. No, thanks. So here I have discriminating union representing days of the week, Monday through Sunday. I have frequency, which is basically that view that's toggling on the right, what days I want to look at, what days I want to, on the left there, of what days a specific task should be. I have a type called schedule task, which is something that has an ID, because everything needs an ID. It has a name, a frequency, which is that type from before, start time, end time, etc. I have a model, which is just a list of those schedule tasks, and a specific display day, whatever tab I'm focused on the right. I have app message. Again, this is everything that can happen in our application, every state change that can possibly happen in our application. We can change the specific name, we can change start time, end time, we can move a task, toggle frequency, we can add a task, and we can toggle the view on the right of what tab we're on. We see here that everything that corresponds to a single task has an int. Int is, of course, the ID that we're going to look up by, which we pass from the view. In addition to that, we have an init. An init has our initial state here. We have our input tasks, which is just a list of tasks that we want to start off with. And we have our display day of Monday. Unfortunately, that's the start of the week. And finally, we have this little empty list down here. I kind of glossed over it earlier. This list is basically a list of app messages. In my case, I call them app messages here, but a list of app messages that should fire initially, upon load. So previously, when I showed them, when I was dealing with them inside of the update function of the counter, they were returned at the end of that. So you return the state, and you also return this list. What happens there is, let's say you want at the end of the increment task being performed and the state being changed, you want to fire a different command. That's where you would do that. You would basically say, at the end of that, I want to call the log event. That's where you could do it. You could register that kind of callback functionality that's built into the update itself. In any case, so unglossed that over.
So this is kind of a continuation that you can post, so that, let's say, for example, you remove a task, you can say, also what I want to do is I want to go and I want to redisplay the screen, set it back to Monday, and do it all over again.
Yeah, if you wanted to call, let's say after this you want to always run these other 5 commands, that's where you could do that.
So you can refresh the screen and do things like that.
Yeah, it'll automatically refresh, but.
Well, I mean, if you want.
Yeah, if you want to literally refresh. Yeah, or something like that. Yep.
Cool.
Yep. So that's that. So that's the first file here. So we can go into the future files. So that's the models. The update is what comes next. Update is a little bit longer. So what we have here is I open up that module's namespace there, or module. And I have 2 functions in here. I have update input tasks, which is something that takes the list of scheduled tasks and return a new list of scheduled tasks. And that is called by the more aggregate update function, which basically says, if we're specifically toggling the view, then just change that, and we don't have to worry about changing the scheduled tasks. But if we're doing anything besides that specific message, then replace the input tasks. So if you're not used to this syntax here basically takes a record type or a record value, and it just returns, it takes an existing one and returns a new version of that with maybe 1 or 2 properties different. So here what we're doing is we're just saying, given a new day of the week for the display, give us that same model and change our aggregate model to that same model and just change the display day. And if we have any other kind of message, then do the same thing, but call this update input tasks. That's hard to say. Update input tasks is not that complicated. It takes a message, which is of any other type besides toggle view, although basically we just return it. And it also takes a model and handles those kind of changes. So in the case of change name, I call it with an ID and I call it with a new name. And from that, we do exactly that. We can call our previous list, just say list map, and if it is the same ID, then return it with the new name. Otherwise, don't do anything with it. And we do that same thing for change start time, change end time. For remove task, we can just return a filtered list that doesn't have that ID. For toggle frequency, just if it's one frequency, give us the other. If you want to add a task, we can take the previous list of tasks and append a new task to it. This is our nice append list operator here, and that's pretty much it. It's basically just given our aggregate state and given a message, what would we do? So pretty simple F# code if you're used to pattern matching and all that. In addition to that, we have some view helpers. So view helpers are quite simply, I didn't want to type all the time. I just wanted really plain T's and TH's. We have a lot of tables in our forward-looking application. And we'll use those in a second here. Our view helpers are consumed by the frequency input. Or no, they're not consumed by frequency input. Because nothing is. It doesn't exist. Gotcha. The view helpers are consumed by single task, which is basically a component that is one of these rows. So we have a helper method here called display frequency, which we're going to have which we're going to use in a minute here. And we also have another helper method called simple input. Simple input is pretty simple, believe it or not. It just returns a TD with an input inside of as one of the children, and on change it should call the action that it's referenced by. And it should also display the value that's passed in. Display frequency just gives text to a specific frequency, DU. So this single task wants to output a TR, or table row. And inside of that, we are going to call this simple input here. And we're going to basically say, we're basically going to call simple input with this. You're probably curious as to what this kind of craziness is. For now, I'm going to gloss over that. You can read the docs, but sometimes you have to do some weird stuff to get the values you exactly want. But basically, this is getting our actual text from our task name. Our task is one of those scheduled task types that are in the model. So again, what's being passed into this is something that's matching this specific type. And given that, we can input that input, which is just dealing with the name change. And specifically, whenever we get a new name, we want to change name with the dispatch. We want to create a TD for dealing with the toggling the frequency. Pretty simple. Register your own click. Take the task ID that we have in the context of this TR. Basically, you can think of it as a function. Call the toggle frequency function, and then dispatch that out to Elmish to be able to handle, and output the current frequency. And then call that same helper method for start time and end time, so we can manipulate those. And finally, create a cancel button on the right to remove a task, which just takes that task ID, calls the remove task button, and then dispatches it out. So pretty simple single task. That's all that's happening in each one of these rows. And you can break that down further if you wanted to, where you could take simple button and make that a component or something. So each of those single tasks are consumed by the input view. And the input view is something that takes in a list of scheduled tasks, takes in the dispatch function, and it outputs everything you see on the left here, at least everything as of this. So first thing, H2. Second thing, create an anchor tag for dealing with the addition of tasks. And all that does is on click, take that add task DU and dispatch it out. So the the Elmish handler can deal with that, and then also output a table wherein for each of the, well, first we're going to create TH with all that boring stuff, but then for each of the scheduled tasks, we want to sort by the start time, so you can consume it in kind of a friendly way, and we want to map it out to a specific view. So for each of those scheduled tasks that are in our aggregate state, we want to iterate through them, call or sort them, and then call that single task view, and then have that rendered within here. So this is starting to look like some real F# here. And you see more and more of this as your application grows. So in any case, that's single task and input task and view helpers. And pretty much the exact same thing happens on the day output. And the output view is just, simple HTML that looks like F#. Or maybe it's the other way around, I don't know. And from there, we have a task scheduler, which takes a list of scheduled tasks and a frequency, or sorry, a display date, whether we want to display on the weekdays or every day. Or sorry, no, just takes a display day, which is the day of the week, and then it filters out what shouldn't be seen given our choice, and then it outputs a scheduled task, which is just the thing that's being printed out on the right, which just has name, start, and end. So it's basically a simplified version of our scheduled task. So here's our task scheduler. We have real F# kind of logic in between our normal views as we need it. And finally, we have app, which is the thing that wraps it all up. Actually, no, we have view, which just has one column for the input tasks and one column for the output tasks. And then from that view, which takes in our aggregate model, we have app. And app is just this. It's pretty simple. It's basically, this is all the Elmish stuff. And it's basically saying, I want to have a program with that specific init, with that specific update and that specific view, and I want to run it at the Elmish app node of our HTML. So right now that Elmish app, you can find a corresponding thing in here with ID of Elmish app, and basically everything's going to be injected in that. And then from there, just run. And that's basically how that's wired together. You build these individual components, and you have a lot of leeway as to how you want to organize your code and how you want to solidify your code, and you kind of wire it up like that. So it's pretty interesting. It's you can build full applications. People have actually taken this further. So this is Fable Elmish. People have actually written Fable Elmish React or native. And so I want to give a minute. So Elmish is actually written on top of React under the hood. That's how it's dealing with all the state change, all the React tools you want to use. You can actually use with Fable Elmish, which is pretty interesting. But in addition to that, there are native frameworks out there for React Native, or specifically, it's called React Native. So what the Fable people have done is they have taken that and they have created bindings for that. So you can create full mobile applications in all F#. So you can do the full stack. And there are actually companies out there with production mobile apps that are utilizing F# full stack right now live. Specifically, Stephen Forkman's company, I know, who's the guy that wrote Packet and I'm forgetting the other one, Packet and Fake, which is a build tool in F# world, or .NET world in general. So that's the Fable Elmish. It's pretty interesting. There's a lot of documentation out there, and I'm sure as of this weekend, when that whole conference is over, I know they're recording things. At least I believe they're recording things. At the end of that, there should be even more documentation. They're probably doing some secret releases here. So that's Fable Elmish. It's pretty cool. You can build full-scale applications within this architecture. So, we've shown off the ability to create just raw F# Fable applications, and also the ability to kind of subscribe to this framework of Fable Elmish, and then work in that system. So in addition to that, we have the ability to interop with client and server. So it's not enough to do F# on the client. It's not enough to do F# on the server. I want to do it everywhere, and I want to use the same types on both sides. I want to interact with that. So I'm actually not going to use these links. As of, I think, yesterday, or within the last week, Stephen Forkman, again, actually created a nice little thing. He calls it the safe system. And what it is, if I go up, is it's a full stack web application written in F# and Fable. So if I go Safe Bookstore, so he has this bookstore app. So what he has here is he has a source folder with client and server projects here. And inside the server, he has this shared folder. And the shared just has his domain logic and his domain models and that kind of thing that want to be consumed on both ends, on the client and the server, including auth and including all that kind of stuff. Sorry, not including auth, something else deals with authorization, but including a lot of interesting stuff. And he can utilize this domain in both the client and the server side here. So if I've stalled long enough, which I haven't, no, I haven't. You can see this all running down here. It takes a little bit to build, but it's pretty useful. Any other questions about Fable Elmish? So this application here is a lovely white screen. Now it's still loading. But basically, it's full stack F#, which is something that really hasn't been too heard of before, unfortunately, which is nice that it actually starting to exist. Okay, so this here is built in full stack F# here. So if I go to login, I can hit test. If I can learn to type. And it's basically a wish list of books, which is cute. I think it's been used in a few books, but that's, you know, the Swap bookstore has used it. It's a frequent thing. But anyway, it's a wish list for books that you want to have. So I can insert new books, which I'm just going to have a bunch of garbage text here. I guess they didn't bother to have validation. I can remove books. I can go home, which takes me to a totally different page. I can go back, etc. It's not too much, but it's full stack. This is actually, if I refresh my page, or if I, funny it's not working. Oh no, I just removed too many things. It went from 2 to 2. If I refresh my page, everything is still there. That data is currently stored on the back end. It's actually in a JSON file right now. But, full stack, it saves if I close this application, came back up, I would still have that full stack. So how's that working? Well, as I mentioned before, the shared file, or the shared folder is used in both of the projects. I have the client, which is this application here, which is using Elmish for all the view type stuff, which, there shouldn't be anything too interesting here for you beyond what you've already seen. It's just more complicated. It deals with authorization a little bit, etc. Or at least a pretty weak authorization. That's something. And on the client, we have, we have a web server, which is pretty nice. So if you want to check this out more, I really recommend it. He calls it the safe thing. I actually don't know exactly what safe is supposed to stand for. But it's pretty nice. It's end-to-end functional first web stack. So I would highly recommend checking that out. Okay. So you can do full stack, and you have client server interop. So as I'm wrapping up, I just want to get into these 3 points. There's a lot of other stuff that exists in the Fable world. We have mobile. You can do Fable React Native, so you can write your full applications within F#. You can actually create WPF applications, also with Elmish. So you can take that same Elmish code and then have that generate WPF and work with it. That's a little bit awkward, I'll be honest, but you can. You can create desktop applications with Electron, which there are really good bindings out there for. So the same kind of TypeScript definitions for web MIDI and web audio that we saw, there are also TypeScript definition files for Electron, such that I can now consume all the Electron bindings and everything in Fable. So there's good samples out there for working with Electron and creating Electron apps in Fable. There's some cool support for WebSockets out there. There are Vue bindings, Bulma bindings, VS Code extensions. I'm actually right now working with someone building a VS Code extension. So there's a lot of cool stuff out there, keeping growing. And I'm sure as of this weekend, even more stuff's going to be out in Fable. Ignore the first half. I think you guys are good by now. But in terms of Fable, these are really good websites to go to. I believe there's actually might be some Fable stuff happening at Open F-sharp as well next weekend. I believe there's probably some kind of Fable stuff. So we should have a lot of recordings coming out soon, which would be nice. There's a lot of cool Fable stuff coming up. So any questions at this point? 'Cause I might be able to give up output. Cool, yeah.
Do you know of any companies that are using Fable in production right now?
There are tons. So I sent out a thing on Meetup. I basically spammed a bunch of F-sharp Meetup groups saying, hey, I have this Fable talk. I want to practice it a few times. What do you got? And a few of them actually said, no, we already have everyone using Fable in production here. But it's definitely used, probably more so on the West Coast. I know I saw job postings for the Bay Area. There's like 2 or 3 places that are opening that have Fable stuff. But yeah, it's employable at this point, which is nice. Better you can say for, I mean, it's not too far beyond asking for F-sharp, so that's cool. Anything else? Yep.
Have you heard about in OCaml they have a library called Incremental, which is used for optimizing the way that you modify your model and things like that, and it helps make things run faster. I don't know if you've ever seen anything like that.
I didn't know that. I thought you were about to say something else. OCaml has Reason, I think they have. No, not Reason. They have basically equivalent of Fable in OCaml. I thought you were going to
Yeah.
I don't know about it.
It's called BuckleScript.
BuckleScript, yep.
They're using it at Bloomberg, and
Yep.
they've made it wicked fast.
Yeah, they were pretty fast by, right? Yeah, they have made it pretty cool. There's a good talk on that. But in any case, no.
Right
What
on.
is that?
What it is it's a is allows you to do mutations, and you do them within a context, and it will basically like figure out all the different transactions you do and then compress them, and then that way things will be done faster rather than copying your whole state and redoing it, which takes forever.
Oh yeah, there are a few things like that. Like React has to do that. You can't just paint the whole view every time.
Right.
You have to create a middle ground where you use virtual DOM and just translate the bits of virtual DOM that change. So this is using that under the hood too. Not incremental, but something similar. Otherwise, you'd get major performance concerns. Yep. Anything else? Cool. Well, thank you guys for having me.